Okay, we talked about the discoveries of Stephen Gray last time, and I guess you saw some of them demonstrated to you by Mr. Van Dam yesterday. And the main discovery that Dufay made was the fact that he could transfer electricity from one object to another. In other words, he discovered what is called electrical conduction. You can charge up one object, have the electricity run through some wire or damp thread, and run onto another object. And Gray proved that you could do that even over distances of 700 feet. And he didn't test distances longer than that, but we know nowadays that we can generate electricity in Hoover Dam and have it run to LA, right? That's why the lights in LA go on. So that technology started back with Stephen Gray and the wet thread that he strung all over his yard. Now, Dufay made, then one other thing I wanted to remind you of last time that was really important. When Dufay couldn't make that discovery, couldn't build his 700-foot electricity conduction line until he had discovered something else. And what was it that, Troy?
That he had to make the thread wet or damp?
Well, no, he actually didn't discover that because he lived right outside of London and it was always damp. So, Evan.
That the nails would, if he tried to connect
right.
the thread through the nails, the electricity would run.
Right. He had to discover you had to hang this this line that you were conducting electricity through. You had to insulate it, basically. You had to support that line with a material that would not conduct electricity, like silk. If you try to do it with iron nails, the electricity just runs away. So Dufay made this very, very important distinction between materials. The materials such as metals were very good conductors of electricity, and other materials like silk were very, very poor conductors of electricity. Electricity didn't seem to go through them at all, and he called them insulators. So that was a really important conceptual distinction that now replaces the old distinction between electrics and non-electrics that Gilbert started out with. Okay, that's all just review of last time. Now I want to tell you about one other discovery that Gray made. And well, first, let me just give you the experimental setup. Let's say that you have a long iron bar. Okay. And you're suspending it, say, using silk. Silk cords. Now, let's say you charge up your glass tube by rubbing it really hard, and you bring that glass tube, so let's call this the electrified glass tube. You bring it up to one end of this iron bar. Now you have some electroscope over here at the other end of the iron bar. Now you don't touch the glass tube to this end of the iron bar. You never touch the tube to the bar at all. You just hold it near this end. Now, what do you think happens? Troy?
The electroscope swings towards the bar.
Yeah, it does. Now, but that's, I mean, when Gray first saw this, he was rather surprised that the electroscope would move before he even touched the iron bar. I mean, all he had to do was get close, and it would swing this electroscope. Now this was came to be called electrification by influence. As opposed to electrification by contact. I mean, we know that if Gray touches the glass tube to the iron bar, that the iron bar will become electrically charged, right? It will be electrified. Now, but what Gray is showing is before he even touches it, and there's no, there's no spark that's jumped between the two, nothing. The other end will swing the electroscope. So somehow this bar is getting electrified in some way simply by the proximity of a charged object rather than the contact. Gray wasn't sure what to make of that, but he knew it was important to write up, so that's the this is the first time that that people found out that you could get electrical effects even without contact. Yeah.
Did Gray publish his own book?
Oh, he didn't actually publish a book. He what was common at the time. Well, in England there was one major scientific journal, and called the Journal of the Royal Society, which was the main scientific society in London. And so if you made an important scientific discovery like this, you could write it up in a short letter just describing basically what you had done and what results you saw, and it would be published in the Proceedings of the Royal Society.
So everything he did, he sent.
Yeah, so he wrote it up. Basically, he wrote up a series of short scientific papers and had them published by the Royal Society. Troy?
Since he did so many things, did they let him go into the Royal Society or no?
Oh yeah, he was a member of the Royal Society. Yeah, if
Was he before or after?
what?
Before he did
Oh,
his discoveries, was
I actually think that he was a member of the Royal Society before he even made his first major discovery in 1729. But I'm not sure about that, actually. Okay. Now, Gray, as I said, Gray had no explanation for this. He just he discovered it, and we'll hear the explanation soon enough, but not for. It's another 15 years or so before someone comes up with a possible theory to explain this. Now, one other thing that Gray wrote up in these papers that were published in the Proceedings of the Royal Society were Something else that he noticed when he had a charged object, and this is the last of Gray's discoveries that I'll tell you about. This one isn't quite as important as the electrification by influence, but it is an interesting effect. He found that if let's say he charged up, he electrified his glass tube, okay? Rubbed it really hard for a while and got it strongly electrified. And then he, say, took a blunt metal object, no sharp end, and moved it toward this electrified glass tube. Now, if he gets it close enough, he found that he could get a spark. And if this this object was blunt, it had no pointy, sharp edge, then he would have to get it pretty close in order to see the spark. But then he would really see a good spark. There would be a nice loud, bright spark. If, on the other hand, he used a pointed object, he wouldn't get that kind of loud, dramatic spark. He could get electricity to transfer to the pointed object, the pointed metal object, but it seemed to transfer without the loud bang, and at a greater distance than it did with the blunt object. So, he didn't know why that was true, but again, he noted that, and he noted the similarity between the electrical spark and the noise it made and lightning and thunder. That in both cases you get this sudden flash of light and a noise that accompanies it. And so he noted, Gray noted he didn't suggest that lightning was really the same thing on a bigger scale, but he said there seems to be some similarity here. So later, someone would investigate that. In fact, I bet you know who. Benjamin Franklin. So, but we're seeing that things are getting set up for Benjamin Franklin here. It's these kinds of discoveries that led to Franklin's interest in this subject and then his researches. Yes, Ben?
So the pointed metal object would not make as good a spark?
Right. The electricity would seem to would leak off to the pointed metal object at a greater distance, but it wouldn't cause the same spark. With the blunt object, you have to get closer, but then there's a sudden spark. Troy?
So there's no spark at all with a pointed object?
Well, he saw some sometimes, but not as dramatic. Okay. Okay. Now, I want to tell you about the next guy who was actually inspired by Gray's discoveries to investigate electricity himself. And that's a French guy by the name of Charles Dufay. And his years are 1698, 1739. For some reason, neither Gray nor Dufay lived very long. Troy.
Was it damp in the part of France that he lived, or?
No, actually it wasn't as damp, and Dufay actually discovers, that's one of Dufay's, Dufay starts out repeating Gray's experiments. And one of the things that Dufay discovers is, first, water is a conductor. Second, strings conduct electricity a lot better when they're wet. So he actually explains why Gray's experiment worked as well as it did, and why some people that lived in drier climates had more difficulty repeating that experiment. Now, as I said, Dufay just starts out thinking that this is a fascinating subject and getting very interested in Gray's experiments, and he repeats all of them. And he actually does them even better than Gray did them. For example, he extends Gray's 700-foot line to about, I don't know, I think Dufay's line was 1,300 feet, and found that it worked just as well. Troy.
Do you ever use long wires? Or?
Yeah, I don't even think he stuck with the threads. I think he was using wires. And the other good thing that Dufay did, that in examining, Dufay was actually fairly well read, and he was familiar with all the work that had gone on in electricity before him, including Otto von Guericke's work, which Gray had never read about. And so, but Dufay was the one who actually summarized in terms of principle the results of all these experiments that had gone on before him. Dufay stated more clearly than Gray had that all bodies can be electrified, but conductors have to be insulated. Okay, stated that as a general principle. And starting from, now remember I told you a discovery that Otto von Guericke had made, that when he would, von Guericke took say he would turn his machine and charge up his spinning glass ball, right? And then if he held say a piece of paper up to it, okay, it would attract the piece of paper, right? What would happen after the paper touched the glass? Ben? Yeah, it would repel. Now, and von Guericke was the first to notice that it's not just that it didn't attract anymore, it actually repelled. Nick?
We tried that experiment a lot and it didn't work.
Oh, wait, that one didn't work with the paper?
Yeah.
Oh, okay. It seems like it should work. But if it doesn't work with paper, you can use something else that worked. Did you find something else that it worked better with?
No.
Oh, okay. Well, but you didn't have von Guericke's super duper machine. Yeah, maybe that was the difference. Okay. But remember that von Guericke actually saw that once that an electrified body would attract a non-electrified body, and then after they touch, repel it. Now, von Guericke was the first to see that, but he didn't state it in principle that way. Von Guericke never said, it's a general truth that any electrified body will attract any non-electrified body, and then after contacting it, repel it. What von Guericke said is, gee, I noticed this peculiar effect when I charged up my glass ball and touched this particular object to it. So now that isn't very scientifically useful. I mean, just to note that you observed this effect in a particular case. Dufay was actually the first to state this in principle, that an electrified body always attracts a non-electrified body and then repels it after transferring electricity to it. So, so let's state that as Dufay's first principle. An electrified body attracts any non-electrified body then repels it after touching and transferring electricity to it. Now, Dufay convinced himself that this was a general principle by, he actually used a gold leaf electroscope. So he had, say, some base, say some silk cord, and then a thin gold leaf. And I think gold was used because gold is a soft metal and you can actually pound it into a very thin foil, so it's very light, and it will move very easily. Yeah, Salem.
So the silk cord held the gold leaf, right?
Well, why is the silk cord important? Did you gotta?
Well, yeah, I'm just wondering how it could go like that,
Oh, well, I mean, he's got some, let's say this part is metal here, and then he hangs the gold leaf from a silk cord, okay, just to insulate it. So the electricity, if he gets electricity on his gold leaf, it won't run away. Okay, so this is what Dufay used. Now, if he takes a glass tube and rubs it and holds it up near this gold leaf, okay, what will happen? Christopher?
It'll turn toward.
Yeah, the gold leaf will swing toward the electrified tube, right? Then, when they touch, what will happen?
Repel.
Right, the gold leaf will swing away and repel. Now, this is exactly what Dufay expected, and that's what he saw. And Dufay actually tried this experiment with a number of other types of materials. He didn't always just use glass and gold leaf. He had other types of metal foils, other materials he could hang there, light materials. He used other objects that he rubbed, and he convinced himself, this is a general phenomenon, that the electrified object will attract the non-electrified object and then repel it once they touch. Troy?
Today will aluminum work well?
Oh yeah, aluminum would work very well. So now this gave Dufay an idea. What do you think is happening when the gold leaf touches the object? Okay, well, there's no point in my even asking that because I've already told you at the end of this sentence, right? Troy?
It transfers a positive charge of electricity. And
Positive, where do you get that? You're reading ahead. Nobody knows anything about positive or any other kind of electricity at this point. It's just electricity, right? That's all they know about. Now, but obviously what's happening when they touch is that the charge, the electrified object, is transferring some of its electricity to the gold leaf, right? And then they repel. I mean, as soon as you see that transfer of electricity, you see the two objects repel. So what does that seem to tell you?
That two
Evan.
electrically charged objects will repel?
Yeah, exactly. I mean, that's the straightforward conclusion that anyone would guess at this stage, is that based on what's been seen so far, a natural thing to think is that two electrified bodies will repel each other.
Is that his second principle?
I'm not going to actually call that a principle. That is a hypothesis at this stage. He has that idea, and you can see very easily why he would have come to that idea, and he decides to test it. Now, how would you test it? Your guess is that any two electrified bodies will repel each other. Nick, do you have an idea?
No, because if you took two electrified glass tubes, it wouldn't repel it enough for you to really feel it.
Well, that's the problem. I mean, you could just rub two tubes, but you've got to have you've got to have a light object that's movable, easily movable. Troy?
you could electrify, you get two electroscopes and electrify two gold leaves and see if they repel each other.
Oh, okay. And how are you going to electrify the two gold leaves?
Well, like by touching them
With both of them with the glass tube?
Yeah, with both of them with different glass tubes.
Different glass tubes. Okay, well, Dufay could have done that experiment. Maybe he did do that experiment. If he did, he found out that the gold leaves would repel each other. But Dufay's really interesting discovery here came when he tried something else. Any other ideas on what he might try? Vin?
This is sort of a guess, but what if two electrified people?
Yeah, okay. And see if they attract?
Or like, I don't know. Yeah.
Yeah, okay. Are you going to pick attractive people or repulsive people? No, that one he didn't try. Nick.
You could try Gray's experiment, charged up an object that's hanging from silk cord, and then he would charge up another glass tube and hold it up to it.
Oh, okay. Well, I mean, that might work, but it turns out that it depends on how you charge the object and what object you choose to charge. Let me just cut to the chase here and tell you what Dufay did that led to this astounding discovery that he made next. He decided, well, let's I mean, he can charge up his glass tube, he can bring it up, and he can touch the gold leaf. Okay, transfer some of the electricity from the glass to the gold leaf. Now, one of the other things that he knows charges up really nicely when you rub it is amber, right? So let's rub a piece of amber and then bring it up to the gold leaf that already has the electricity on it from the glass. Okay? Now,
Pushes back.
It's
what happens? Now, according to his principle that electrified objects should repel, the charged amber now should repel this gold leaf. I mean, the glass tube repels it. If you hold the electrified glass tube up near this gold leaf now, the gold leaf jumps away. He takes his rubbed piece of amber, he holds it up close to the gold leaf, and the gold leaf just jumps at it, attracts it. The amber attracts the gold leaf even though the glass repels it.
So could there be different electricities?
Yeah, see, that's the only conclusion you can come to at this point, right? That there have to be two different kinds of electricities. Does everybody see this? I mean, I should actually, you've all got this first principle. Let's get rid of that. This is a crucial experiment. So let's just go through it. Here, I'll call it crucial experiment. So step one, you've got, so let's say electrify gold leaf with electrified glass. Okay. Now, by the way, if you bring some other, I mean, let's say you take a glass tube that you've rubbed, okay? You touch it to the gold leaf. You know that they repel now as soon as you touch them. If you rub any other piece of glass, bring it up to that gold leaf, it also will repel it. Okay? But if you let's go on to step two after. If now you electrify amber, say, you find that the electrified amber will now attract the gold leaf. So obviously it's not the case that all electrified bodies repel each other. Here's a counterexample. What would you try next after seeing this? Troy.
using lots of other objects and categorize them.
Exactly. That's exactly what Dufay did. At this point, he realizes there's got to be two different kinds of electricity, depending on the object that you rub. So at at this stage, now obviously, if one other part of this principle, given the fact that the gold leaf was electrified with electricity from the glass. Okay, so they have to have the same kind of electricity, right? The glass and the gold leaf. And they repel. The amber has to have a different kind of electricity because it attracts the gold leaf. So it must be the case that the same kind of electricity, I mean, if two electrified objects have the same kind of electricity, they repel. If they have different kinds, they attract. Neve.
What happened when the amber touched the gold leaf? Did it repel again?
Oh, if the amber touches the gold leaf, there it would depend on exactly how much electricity was on the amber and on the gold leaf. But if they had about equal amounts of electricity, then what would happen after you touched them is they wouldn't have any effect on each other at all anymore. The electricity of one would seem to cancel out the electricity of the other. Oh, yeah.
And would this be, so if you took after that the amber and used on a piece of paper, it wouldn't pick it up?
Right. Right. Troy.
Would it like be neutralized since they're two different types of electricity working in the same object? Or
Right. Right. It's like if you have now, of course, they don't have any way of measuring quantity of electricity at this point. But what you would get in practice is not a complete cancellation of all electricity, because the chances of having the same amount of electricity on the amber as you'd have on the gold leaf are pretty small. But you would get a lesser attraction between them. Troy.
so is electricity kind of like magnetism a little bit with like two different types?
Well, no. This is a different phenomenon than magnetic poles. I mean, you've still got this this case where you can have an object that has one kind of electricity. Okay, you can't have a magnet that is just a north pole or just a south pole, because they always come together. So that's still a fundamental difference between electricity and magnetism. Okay, now Troy suggested earlier that what Dufay should do at this point is do an investigation of all kinds of different materials and see which materials have which kind of electricity. And that's exactly what he did. Let me see. Now Dufay basically, I won't bother to use his exact terms, but in essence what he did was he said there's a glass type electricity and amber type electricity. And of course, the electricity that we find on glass is glass type. And amber has amber type electricity. Now what else? He found that precious stones. So diamonds, opals, sapphires, they all had the same kind of electricity as glass when you rubbed them. And even animal fur has the same type of electricity as glass.
Was he
Say
really rich because he like got to test with diamonds and opals and gold and stuff, or was it not much back then?
Actually, I'm not sure.
Borrow it from Jupiter.
What?
Did you get a grant?
Yeah, you probably got to. Well, this is France, so France was the first to jump on board, actually supporting scientists with the king's money, or with the people's money that the king had stolen. But actually, I'm not sure in Dufay's case. I mean, I don't think that these. I think jewels were a little more common back then, maybe not worth quite what they are today, but I'm not sure about that. Anyway, he had access to them, whether they were his or not, and he did do experiments.
Was amber the only amber type?
And no, amber, let me see, silk, he showed, is the same kind of electricity as amber. Paper is the same kind of electricity. There's another resonant solid that is somewhat like amber called copal that is on this list. So he found a number of, and I haven't even listed all of the items that he tested, but he found a whole list that had the same kind of electricity as glass and a whole list that had the same kind as amber. Neef.
Why is it the precious stones like amber and copal were different from diamonds and opals?
Oh, well, they are very different types of substance. For instance, this is fossilized, tree sap, basically. And diamonds are a highly compressed form of carbon. I mean, we'll eventually find that out. But they're much different materials. So I guess it's, from that point of view, it's not that surprising that they could have different kinds of electricity. But I haven't told you anything about exactly, what underlying property that the items in one category share that is different from the items in the other category. It would take scientists a long time to figure out exactly why a material fell into one of these categories versus the other. Evan.
I wouldn't. Oh, never mind.
But at this point, I mean, this is a remarkable discovery right here. I mean, this is the kind of discovery you have to make first, is that there are two kinds of electricity. Troy.
What type were metals? What type were metals?
Oh, that's a good question. I'm not even sure. Yeah, I don't know. I don't know whether. Oh, and we're done for the day.